This protocol, intermediate system to intermediate system, is a very old routing protocol. I tell you, even before OSPF, even before any other routing protocol, this was there. And basically, it was built for a different network layer. In fact, if I need to say in a clear way, when ISIS was designed, there was no OSI. There was no OSI layer approach. See, OSI is the foundation of networking, correct? But this ISI's routing protocol was designed before the foundation of networking. So you need to understand that this protocol don't stick on to the rules. They don't fit into the framework. That's what we need to understand from this. See, ISIS is not a protocol that you can call it as layer 3 protocol or layer 2 protocol or layer 4 protocol or layer 7 protocol. This has got no boundaries, no limitation. OSPF has got boundary. OSPF is a layer 3 protocol. EIGRP is a layer 3 protocol. RIP is layer 4 and 7 protocol. Layer 7 protocol is BGP. Now you see, ISIS, before OSI layer, ISIS was designed. That's why I'm saying you cannot fit this protocol in any layer. But if you wish to fit, or if you want to use this this as a routing protocol, it will support. If you want to use this ISIS as a LAN protocol, as a switching protocol, it will support. What I'm trying to say here is, you can tune this ISIS to fit into any layer. So the ISIS that you are going to learn today is not the real ISIS of the ancient days. It's a modified version of ISIS. It's a modified version to fit into OSI layer 3.
Okay.
Yep. So when you say ISIS, it's not only used as a routing protocol, it is used in various other places, especially in Cisco data center. There is a concept called fabric path that uses ISIS. It's a layer 2 technology. Layer 2 technology using ISIS. Example, fabric path. You got that word? Fabric path? Fabric path.
Yes, fabric path.
Fabric path. There is another data center technology called OTV. OTV. Overlay transport virtualization. OTV.
OTV, okay.
All these technologies uses ISIS. So not only layer 3 routing protocol, even many other layer 2 technologies.
VXLAN.
VXLAN, you can use ISIS, you can use OSPF, you can use anything like VXLAN is a technology that works on top of layer 3. So your wish, as a layer 3 protocol, you want to use ISIS? Yes, very well, you can use it. But again, I'm saying you are using as layer 3 protocol. In VXLAN, you are using as a layer 3 protocol. But I'm trying to explain you that ISIS is not just a layer 3 protocol. It can fit in any layer by tuning it. Example, fabric path is a layer 2 technology. ISIS is the routing protocol that is used in the fabric path. Segment routing. In service provider track, we have something called segment routing.
Right.
In segment routing, to carry the segment IDs, this link state protocol is more suitable. Even OSPF is used, ISI is also in use when you come to segment routing. So ISIS is not a new protocol. ISIS is not designed to support OSI. ISIS originally was a different protocol. Later it was modified to fit into our today's networking world.
Right.
Now, this ISIS recently, the modified version was supporting a network layer protocol called CLNS. CLNS. Have you heard about CLNS?
No?
Okay. CLNS was before IP. CLNS was before IP. It was after OSI, but before IP.
Right.
So you had a OSI reference model, but the protocol layer 3 was CLNS. Network layer was running not IP, it was running CLNS. What does
Right.
CLNS stands for? Connectionless network service. CLNS, connectionless network service.
Right.
CLNS. So to support CLNS, ISIS was modified from the original version. Later, it got modified to IP version.
Right.
So the reason why I'm mentioning CLNS is some of the commands, when you do the lab, you need to type CLNS. You should not wonder why I'm typing CLNS, because ISIS for CLNS is supported in Cisco.
Okay.
Later, IP also got added. So some of the commands are there in IP as well as CLNS. So when you do the lab, you will type CLNS and get a result. Similar result you will also get by typing IP.
Right.
So there is nothing more I want to explain you about CLNS. What you need to understand is CLNS is an older version of IP,
Right.
and ISIS was supporting CLNS. Now it supports IP. So some of the commands will also have CLNS in it.
Right.
See, there are people who never uses that CLNS command to see output while troubleshooting, but I always use both IP command as well as CLNS command. They give almost similar output, almost similar, not exactly, almost similar output. So I want to use both.
Right.
So in this chapter, we are going to see the introduction to ISIS and integrated ISIS routing. You see, this presentation, when it was designed, we were in old age. Yeah. What I'm trying to say is there are some terminologies that you'll see like ES, end system. Those things are no more in networking. So
Okay.
in this presentation, a few things we will ignore. I'll tell you what to
Oh,
ignore.
okay.
Now, what is special in ISIS? It's a protocol that can be enabled in ISP. ISP is a large network. So in a large network, ISI is a suitable protocol. So the US government made it as a mandatory to support OSI OSI to support ISIS and IP. So that's the actual story. How ISIS was developed to support IP because it's the pressure from the government um, to use ISIS as a routing protocol for ISP. This is the story, which I heard, which is there. Now, what does this IS stands for? IS stands for intermediate system. What is the intermediate system? Router is the intermediate system, isn't it?
Right.
In between two computers, you have a router as an intermediate system because these two computers are in different network. So whenever we have devices between different networks to communicate, we use an intermediate system called router. So instead of calling router to router, they call IS. Intermediate system to intermediate system routing protocol. As I said earlier, ISIS was originally designed as IGP for CLNS, which is a part of OSI protocol suite. So before IP it was CLNS. You got that point? Second point?
Yes.
Yeah. So before OSI it was different story. This story begins from OSI. So when OSI is already in place, ISIS was tuned, designed, altered to support CLNS. The OSI protocol suite layer 3 protocol is CLNP, Connectionless Network Protocol. So to support CLNP, CLNS version of ISIS is introduced. ISIS uses CLNS address to identify router and build links to database. You understand this? So we are seeing here there is a special address called CLNS. IP is 32-bit. IPv6 is, I don't know IPv6, 128-bit.
I will say 128 bits.
128-bit. The CLNS is neither 32 or 128. This addresses are different. You will see little flavor of CLNS in ISIS configuration. I'll show you where. So ISIS uses CLNS address in order to identify router. See, in OSPF, we use router ID to identify routers. What is the size of router ID? 32. Isn't it? 32-bit. 32-bit. So it copies one of the loopback interface address. And using that router ID, the link state database is built.
Right.
Whereas this ISIS uses CLNS address to identify a router. Now, the CLNS address is what we call it as net ID. What did I say? Did you hear me? What did I say?
The net ID.
Correct. Net ID. This can be between 8 byte to 20 byte size.
Okay.
We'll talk about this in detail in coming slides. So we got a special address called CLNS address, which is used to identify a device in ISIS domain. We are not going to use the router ID. Now, some of the features of ISIS. As you say already, it's a link state routing protocol. And this supports variable length subnet mask, meaning it is a classless classless routing protocol.
Right.
Now this ISIS uses same algorithm what the OSPF uses, Dijkstra's algorithm, which is also called the shortest path first algorithm. This algorithm, you know very well about this algorithm. This is
Right.
a binary tree algorithm. So the low cost is what the preferred path. Now, this is also a link state routing protocol that is using this SPF algorithm. So the convergence is faster because the link state advertisement, we call it as LSP here. We don't call it as LSA. I repeat, we don't call LSA. We call it as LSP. What is LSP? LSPDU. LSPDU is what in short called as LSP. Link state packet data unit. You can also call this link state packet in short.
Right.
So this LSPDU or LSP is what exchanged in between the routers to share the route information. It's the link state advertisement, LSPs, what link state advertisement. So same like OSPF, ISIs also send the hello packet to establish adjacency, but exchanging is not LSA, it is LSP here. The link state packets are exchanged.
Right.
So now this ISIS uses the bandwidth, memory, and processor in a very efficient way. How? There is no periodic update like what you see in OSPF. In OSPF, whether there's change or not, every 30 seconds they do what? They do resync. 30 minutes.
Oh, okay. I was going to say it's 30 minutes.
Correct, no?
Yes, it's 30 minutes.
Yeah,
You
30
did
minutes.
suggest a 30.
30 minutes, right? Every 30
Yes.
minutes, OSPF sends updates in order to get synchronized. DBD. They send DBD to make sure they are synchronized. We don't have those things here. And there is no periodic refresh, nothing like that. So whenever there is a change, only the change alone will be sent to everyone. So bandwidths are not unnecessarily utilized. Memory and process are also not going to be utilized because you're not going to send too many updates.
Right.
Now, I also want to mention here the other reason why the process is not much utilized is there is no concept of auto cost. In OSPF, cost is calculated automatically. How? In
Oh,
OSPF, yeah, in OSPF, cost is calculated automatically by using what? By using bandwidth, isn't it? By
yes.
taking the bandwidth, the cost is calculated in OSPF. ISIS never cares about your bandwidth. So there is no auto cost in OSPF. Sorry, in ISIS. There is no auto cost in ISIS. Then how is the metric calculated? And what is the metric of ISIS? Do you know any idea? Do you have any idea about metric of ISIS? Have you heard?
No, no, I have never.
It's the same cost, but there is a huge difference. When you say cost in OSPF, what do we say? What do we mean? We mean that bandwidth is utilized Based on bandwidth, the cost is calculated, using which the shortest path is calculated. So based on the bandwidth, the cost is calculated in OSPF. For that, there is a
Right.
process utilization there. We don't have such thing in ISIS. In ISIS, bandwidth is not used. And how is the cost calculated? Cost is fixed. Cost is fixed. What do I mean by fixed? If I have a link, whether it is a gig Ethernet or fast Ethernet or serial, the cost is going to be 10 per link. 10 per link. I repeat, if I'll have A to reach B, according to ISIS, you know what will be the cost? 10 plus 10 plus 10 plus 10, 40. Here you may have gig Ethernet. Here you may have fast Ethernet. Here you may have serial wire. For all speed, whatever the speed may be, whatever the bandwidth may be, that doesn't matter. The cost is always 10. But you can go and change it.
Okay.
You see, the cost is fixed cost. So if you will have two paths, this is only Ethernet. According to ISIS, this will be the best path. You know why? Low cost, isn't it? 10 plus 10 plus 10,
Right.
30. Which you may
Right.
not like it. You may not like it because it's Ethernet. You may not like it. So what you can do is, you can go and increase the cost to 30 here manually. So now it becomes 50 bad cost. Automatically this will be the best path. You got it? So
Yes.
the cost is not auto calculated as per the bandwidth. The cost is 10 by default, whatever the speed of the interface may be. The cost is 10 by default. But if you wish to tune it, you have an option to tune the cost. You can very well go and change the cost. You can say ISIS consider cost as 30. So ISIS will take it as 30. Okay, so that's about the cost. Now let us talk about the two routing levels. ISIS supports two routing levels. Please
Can I
understand.
ask a question? Can I ask
Yes,
a question?
question please.
Does ISIS support this contiguous network?
Yes, of
Okay.
course. That's why we call this VLSM.
Okay. Okay.
Variable and subnet mask. Of course, it supports discontinuous network, classless discontinuous network.
Okay.
All that supports VLSM supports discontinuous network.
Okay.
Now, uh, there are two routing levels of ISIs, level 1 and level 2. Level 1 is equivalent to, please focus on my words. Level 1 is equivalent to type 1, type 2 LSAs in
Okay.
OSPF. Level 1 is equivalent to type 1, type 2 LSA in OSPF.
Right.
Level 2 is equivalent to type 3, 4, 5, 6, 7. Level 2 is equal to type 3, 4, 5, 6, 7. In another word, what I should say is level 1 is within the area. Do you agree with me?
Yes.
Because type 1 and type 2 is what? Within area.
Right.
You see, routes within area. L1, level 1 builds common topology of system IDs. I'll talk about the system IDs coming later. in local area only and the routes within area using the low-cost path. So within the area, there are many networks. To reach those destinations within the area, L1 is used. You just remove that L1 and put type 1 and type 2 LSA. It's the same meaning. What do we have to reach the local net destinations within the area? Within the area, what do we have? We have type 1 and type 2 infos. Using that only you reach the destination within the same area. Will you use type 3 LSAs to reach the networks within the same area? No. It is type 1 and type 2. Similarly, it is the L1 adjacency and L1 advertisements. LSP of L1 are nothing but the routes within area, local area. So there will be two different database in ISIs. One for within the area, the other one for between areas. What is between areas? Like type 3 LSA, we have level 2. This exchanges prefix information between areas. Routes traffic to area using low cost path. So, other area destinations you will learn through type 2 level 2 ISIS. Level 2. Level 2 exchanges the prefix information of other area to this area and this area to other area. Level 1 is about the same area network. Level 2 is about the other area network. Any question? Are you there? I'm unable to hear from you. So, anyhow,
Yes, I am
thank
here.
you.
Yes, I'm here.
We understand here there is going to be multiple areas like OSPF, but
Right.
they are not same like OSPF. There is a big difference between OSPF area and ISIS area, which we are going to see in the coming slides. So what you see here is there are multiple areas. Within the area, L1 adjacency. Between the areas, what adjacency? Between the areas, what adjacency we will make? L2. Within area, L1.
Right.
Okay. See, you should have got a lot of information in this page. Not that simple. This page has got very good introduction, especially this last two paragraph. Two levels. Level 1 is a database which has got information about the destinations within the same area.
Right. Like intra-area.
Yeah, intra-area database. L2 is the inter-area database. I want to repeat once again with more clarity. L1 will have a separate database. L2 will have a separate database. You don't see such thing in OSPF. In OSPF, you have only one database for type 1, type 2, type 3, type 4, type 5, type 6, type 7. All LSAs, only one database.
Right.
OSPF has got only one database with all LSA types.
Right.
ISIS has got two separate databases, one within the area database, which is L1 database. Another one is between area database, which is L2.
So that means you use two separate commands to look at a database.
Yes. If you want to see separately, you have separate commands. If you want to see together, you don't need to mention, then it will show both.
Oh, okay. Mm.
And you don't mention whether L1 or L2, it will show both.
Show both. Okay.
Both, it will show, but it won't show mixing both. It will show in a two separate tabular column.
Okay.
In one command, you can see two separate tables.
Right.
L1 database and another one is L2 database. Right. Now, as I said, ISIS has got multiple areas. Now, if you see this picture here, this very clearly explains that there is no area 0 in this picture. Yes. In OSPF, we have area 0 only to act as a backbone area.
Right.
Area 0 is reserved to be a backbone, to be a transit in OSPF. You don't have such reservation in ISIS.
Right.
In fact, there is no connection between area ID and backbone. I repeat, in OSPF, there is a connection between area ID and backbone. What is the connection? Area 0 means it is backbone. That's the connection.
Right.
Can you have backbone without area 0 in OSPF? Not possible. Not possible. You cannot have a backbone area without area 0 in OSPF. But you can make use of any area to act as a backbone in ISIS. I repeat, you can make use of any area to act as a backbone area. Here in our example, area 2 in this picture is acting like a backbone area.
Right.
But the truth is, it is not really having any special configuration. It is having L2 on the router that connects to other area. That is the only configuration that makes area 2 to act as a backbone. I want to repeat it. This area 2 has accidentally become a backbone. It is not intentionally configured by us. It has become a backbone because this has got L2 to call to learn the network from other area. It has got L2 to learn the network from other area so that it can give it to this area whatever it learned from area 4, and it can give it to this area whatever it learned from area 1. So it's an accidental backbone area
Right.
because it has got L2. See, this is L1 only. It won't
Right.
learn other area routes. This is L1 only. It won't learn other area routes. So area 1 routes are learned by L2 and carried by L2, carried by L2, carried by L2 and given here. If you don't have L2, say you don't have L2 here, it is L1. Now this cannot be a backbone. This cannot act as a backbone. Why? The other area routes are here but cannot go here because there is no L2. So this router will never learn about area 4. Likewise, this router will never learn about area 1 because this middle router is not ready to learn other area routes. You understand?
Correctly.
Because these routers, consecutive routers are L2,
Right.
and this is also L2, this is also L2, and this is also L2. The routes of other area come here and go to other areas like this.
Yes. Yes.
So that is why I said accidental backbone. It became an accidental backbone. If you make it as L1, he cannot be a backbone. This is going to be a separate area. This is going to be a separate area. They're all break into pieces. They cannot converge if you make this as L1. So it is the L2, the one which is making this area as a backbone.
Okay, could you use static route instead?
Yeah, you need to do redistribution again. Static route and then redistribute into ISIS. And then again take the static route, redistribute. That's a big complicated stuff.
Okay.
Now, let's read this one. Routers are identified as L1, L2, or L1, L2. See, by
Yes.
default, ISIS is L1, L2. By default, ISIS, when you configure, it is L1, L2, meaning it will run both the process. It is going to run two ISIS instance. I repeat, it's not one protocol. It is two protocol when you enable ISIS. Yes, to make it clear, I'm using the word two protocol, but it is one protocol. What I'm trying to say is it is going to maintain two separate process, two separate
Right.
database. Everything is going to be two by default. By default, both L1 neighbor and L2 neighbor will be formed. When you don't say,
Right.
I want L1 only, I want L2 only, when you don't say that, how many neighborship, between these two? Two neighborship. Everything is two. There will be two hellos going, L1 hello, L2 hello.
Right.
So there will be a separate neighborship for L1, separate neighborship for L2, and also separate database maintained for L1 and L2. But if you want to make a router as only L2, you can do so. Or only L1, you can do so. What will be the difference? When you have L2, you will have routes of all other areas. When you have L1, you will have only local area
Local area.
destinations. So in the routing table of this router, you will see only the networks of local. Nothing from other area you can see. You understand? Now you may ask a question, then how can I ping other area network?
Yes. Right.
That is why I love ISIS. You know what? Even though you don't have stub configured, this is a stub area. Meaning you will have a default route pointing towards the closest L2 router. Automatically, when you have only L1 relationship, this L1 L2 router will inject a default route, like a ABR injecting a default
Right.
route when you configure stub.
Mm-hmm.
Like a ABR injecting a default route when you configure stub here in ISIS L1 L2 router. You don't need to say anything. This is the default behavior of ISIS. The reason why I like ISIS much is this point is easily achieved.
All right. You're 3 minutes away from 5:50.
Oh, sorry. Okay, now let me quickly wind up with this page. You see, what I'm trying to say is you will have a default route given by your L1, L2 router. Using the default route, you can go to any area. Now, will there be a default route on area 3 router? No. No, because it's L2, it'll have detailed routes to other area, isn't it?
Yes.
Yeah. Now, will I have a default route in this router?
Yes.
Yes. Will I have a default route on this router? No.
Going back to yes, going to L1.
No, this one will not have any default route. This will have a
Oh,
detailed routes of local area because you have L1 and detailed routes of other area
oh,
because you got L2.
L2.
All
Okay.
right. So we'll stop here. Hope